My name is Paul Henschel. I'm a German open source developer. I am employed in a small Swiss company called AWV. And today I'm going to talk to you about a React library that I made called React Fiber. Basically, it started all here because at work, most of what we do is related to CAD, 3D, industrial design. And at some point, I decided to push my problems more into the open, to develop in the open source scene. And this is how React Fiber first started. And I give you a small impression. One of the first tweets I made, it reads, web-based CAD system we develop in Switzerland, written in React, and 3 is taking shape. Still baby steps. That was a very early beginning of what we were doing on the client, but you can see the makings are all there. The frontend was made in React, and at this point, the scene-related stuff was made in Three.js, plain Three.js. Eventually, the problems became grave enough so that we had to scrap it because complexity grew in scale. It was very hard to work with. Nobody understood how to maintain this anymore. And the project that we are working on now is called Buerli, B-U-E-R-L-I. You can check it out, buerli.io. And this is completely based on React Fiber on the client, and this is where really it comes from. This is the origin. And you can see here some 3D stuff floating around, perspective shift. But what it really does at work, what Buerli does, is it's like a small CAD system for the web. Something like, if you've ever heard of it, Blender, like a modeling software. You can make complex constructions, models, you can cut out stuff, even, I don't know, plug and play together your own CAD system if you want to. So this is the history of React Fiber. This is how it all started. You can check the project out here. It's on GitHub. It's completely open source. It's on the React Spring organization. There's lots of fancy demos on here, lots of informations. I don't think I will go into the basics and fundamentals because you can check out these links and start learning yourself. I will more focus in this talk on how React helps us to bring some sanity into our work. And in order to explain what React Fiber is, basically in technical terms, it's a React reconciler for Three.js. I know that sounds complex, but bear with me for a moment. So Three.js, for those of you that don't know what this is, it's in itself an abstraction for WebGL, so pushing graphics onto the GPU. I've heard this often, that some people say 3D on the web is like gimmicky, but I don't think it's true. 3D doesn't have to mean, I don't know, flying dragons and fireballs. It can be subtle. You can mix stuff into your HTML. You can basically do a lot, and if you can say one thing about WebGL, it's very, very fast. It's super performant. And Three.js is an awesome project. They abstracted a little bit because WebGL is very prototypic, very low level. WebGL doesn't know what a camera is. There's no scene and stuff like this. So Three.js basically abstracts it in a very nice way. It's class-based, and each of these constructs is completely self-contained. And it's great that way. So when I started to look into this, I came across this project. It's called React 3 Renderer by Toxic Fork. And this is, I guess, what most people would call a binding. What is a binding? It is when you wrap each and every construct or object into its own component. The problem is that Three.js has hundreds and hundreds of components. So this is what they are doing here. All the shapes, all the geometries, all the lights, materials, objects. It's one hell of a task to maintain this. And I guess the problem is also Three.js because they introduce breaking changes practically every month. So you figure out that something is wrong when it's crashing. That's how it works. They don't have proper versioning. So to figure out what changed, you need to go to change sets and stuff like this. So I guess that must have been the reason why this project eventually left off. It died, I think 3 or 4 years ago. So the problem with bindings is this: as a user, you hand over the success of your application into the hands of someone that may or may not maintain this forever. And if they stop maintaining it, it's basically over. So as an example, every geometry that was merged in Three.js over the last 2 years isn't in here. So this one is tied to a very specific Three.js version. So we knew that this couldn't be the solution to our problem. So I looked on and I found this. It's called React Reconciler, and it's an awesome project. One of my favorites, actually. I was listening to some podcast of the original React gang, so to say, and they said React is something very special. They saw the potential that it has because it's not bound to a singular platform. React can render everything, and I'm so glad they followed through with this vision. And this project is what allows you or anyone to go through with it, because you basically create a small config, and this config teaches React how to render on a foreign platform. React DOM, for instance, is a reconciler. And the reconciler says, I have spans and divs and h1, I have certain colors, and it teaches React and says, please, this is the data, and now express this in HTML. And there's many more, like React Native expresses views in iOS and Android and so on. So React Free Fiber is basically this. It's a reconciler. I guess the most beneficial is that it's not reliant on a version. It's basically future-proof. I show you the first ever commit that I made. I copy-pasted this in a code sandbox. So this was, I think, 50 months ago. It's how much? 160 lines, more or less. And in these 160 lines, I could do everything that React 3 rendered it and more. And the way it works is as follows. As you can see here, we are now able to declare something that used to be imperative. Previously, you would write new 3, what's that, group. And in React and JSX, you can just place an element in here and say group or mesh or camera material and so on. And the way it works is as follows. This is the config. This is the config that you need to fill. It's this bunch. And I guess the most important function is this one, create instance. And you get passed a type. This is the type that you get here in the JSX. So if I do anything, it doesn't make sense now because Three.js doesn't have this. But then the reconciler, now it crashes because it cannot find anything in Three.js. So remove this real quick. My job in here is to create a object, a real Three.js prototype, for instance group. I do this by just passing in the type in here, and I hand it back to React. React doesn't know what this is, it doesn't know how to deal with it, it just maintains it for me, it stores it. And there are a couple of other interesting functions, like append. It says what happens if someone appends something and they hand me the instance. This will be the group or the mesh or the camera. And then it's my job to append the child. And the same happens for removals, inserts, prop updates, and so on. And with very little code, you have something that's future-proof because it works forever. Actually, it's pretty cool because this red cube, it's using the newest Three.js version. And this state is, like I said, 50 months old. So it could still handle everything that Three.js did without any change whatsoever. So that's why I went for the reconciler. And obviously it grew from there, but this is how it started. The original problem that we faced at work had to do with user interface making, separation of concern, a little bit like this. Made a small demo to showcase it. So what we have here is a cube. That's the first property you can easily recognize, and it's yellow or orange. So that means it has a material. It's also spinning in 3 directions, or I think it's 2, X and Y. You can hover it. If you hover it, it gets red, and if you click it, it gets enlarged. It's bigger in scale. So these properties are very easy to see. They're obvious to describe, but to express them in Three.js is not so easy. I needed 70 lines to do this. And obviously, most of it is typical Three.js boiler code. Three.js is very boilerplatey. So you can forget that you can just sit down if you have an awesome idea and prototype it. You need to wade through math and stuff like this. It sucks a little bit, but React Three Fiber abstracts it away completely. And here's the same version in React Three Fiber. I made a small comparison side by side, and you can already see that the difference is pretty big. React Three Fiber is not even half of it. And the problem is this: if you've ever used Three.js, you will have noticed that your application is split into a couple of sections. I have color branded them. So we have state, your variables live there. There's setup where you create all the primitives, the scene, cameras, and so on. Then you have the view. This would be you filling the scene. In this case, our scene just consists of this little cube right here. And then we have a section for responsiveness. Responsive means that Three.js is not responsive by default. So if you have a canvas that needs to adapt to size changes, you need to code it. There's a section for events, so you can hover it, you can click it. Three.js does not have events, they only have raycasting. So basically you also have to do it manually. And then there's the render loop. It runs 60 times per second. And this is where you commit to the GPU. And the problem is right here. We know what we wanted to do. We had a cube, orange, spinning, hover state, active state. And I'm searching for the cube now. Yeah, and you can see it. Everything is lighting up. The cube is involved in every piece and corner of the application. It's basically involved in everything. Obviously, it's involved in the creation because we need to create it. It's involved in the responsive section, and it mutates it because the cube grows and shrinks if we change the viewport. It's involved in the event section for mouse move and mouse click because we can hover it and click it. And it's in the render loop because it gets to spin a little. And if you look on this side though, on the right side, you can see that we don't have this problem. The entire complexity has been encapsulated and packed away into this one component, and it's completely reusable at this point. This component is managed by React. It bears its own state. It's responsive. It has access to the render loop. It has its own events that it declares. These events are the same that you know from the DOM. They are pointer events, which is also super beneficial because you get to use any library that can use events. You can use it now with meshes and materials and so on. And it's reactive because you can reactively respond to properties. So we have the same thing over here running in React. And because it is React, we can now reuse it. Now I have 2 cubes in the scene. And so let's push this one elsewhere. And now it looks like this. They are completely self-contained. They have their own events. They have their own active state. They could share state. I could use Redux. Basically everything. And this is a huge upside for us and I guess for everyone. There's another perspective I wanted to talk about, and this goes a little bit into performance and mixing 3D with HTML. Someone linked this page to me, and I thought it's crazy because I've never seen a experience like this, and I just knew that none of the tools that I have at my disposal could do this. And at this time I was already involved in React Spring, so I knew a thing or two about performance and animations, but this was something completely out of the ordinary. I couldn't do it. And I started to investigate and ask around. I have a couple of friends working in agencies, and they basically explained to me that people that do this aren't even called front-end developers. They are the 3D talent. That's the moniker they go on under. And I guess this split in the communities is because front-end and WebGL seems so different. There's a huge gap in between the two. And I tried to solve this a little bit with React v-Fiber, make it a little bit easier for people like me, for front-end developers, to tap into this huge potential. And starting off with performance, there's this article written by Paul Lewis in 2012. And it's teaching how to make a parallax looking like this. And I guess my short attention span wasn't as short as it is today. So I'm reading this really line by line, and I have a code editor, and I'm trying to realize the examples that he has. And he says, of course, you have a div and you have a sphere and some text, and just use the most obvious property, which is top. So you place these elements on the screen using top property. I'm doing this, and it's basically lagging like hell. And he says, of course, that's your fault because you didn't use transforms. So I'm trying transform, still lags. He says, yeah, because you need 3D transforms. I'm trying this, it's still lagging. And he says, yeah, that's still your fault because you didn't use the will change property. I'm trying will change and it's still lagging like hell. And back and forth. In the end, he says, oh, why don't you just use Canvas and WebGL? And I felt a little bit betrayed or pissed at this because I thought, why the hell did I just learn all this if the DOM basically just chokes trying to shift 10 elements on the screen? And I think it's even worse than this. I think we have forgotten how fast computers really are. I found this example is not done by me, but it's pretty awesome. What we see here is just a cube running up and down, and now we can scale it. So we have 2 by 2 cubes. And now we have 5 by 5, 10 by 10, 20 by 20. This is already an amount I don't think the DOM could handle. If you have 20 by 20 divs and you're shifting them around all at the same time, it will just choke. But now I can go higher. I mean, this already looks crazy to me. 500 by 500, and now we have 1 million objects. If I go out, it appears like a flat surface. But if I zoom in, you can see that it's actually still alive. All these cubes are moving at the same time, 60 frames per second. So computers are very fast, and the GPU is very fast. And the DOM, I guess, because of years of backward compat, or I don't know even what is the reason, the DOM is very slow. So I started to investigate how to make it easier to incorporate 3D, or it doesn't even have to be 3D, it can be 2D, but on the shader, on the GPU. How to incorporate this into web pages. And the first thing I want to show you is a relatively new library I made called Three. It's German for 3. And it's a collection for utilities, helpers, and so on. And one of these is the HTML component, this one. And the way it works is like this. We are back to our cube example. And now let's make it not spin. How about making it go up and down? So I have my mesh, I gave it a reference, it's over here. And with this reference, I can access the actual object and mutate it. This is pretty special because Three.js has a render loop, and it's totally fine to mutate your view inside the render loop. It's safe inside useFrame. And if this component unmounts, everything is cleaned up. All the side effects go away. So basically, let's access it. Mesh current. We know we want to move it up and down. So I'm accessing the Y property on the position. I take a sine function, very easy. Take my clock that I get elapsed time, and now it's traveling up and down. And let's put some HTML right into the canvas. I'm using the HTML element from this library called Three. Place it in here. close it again. Let's say h1 hello and closing it. And there you go. It's very easy to mix these two. So this element is right like smack in the middle of the Three.js scene, but it gets transformed automatically now. So that makes it very, very convenient and comfortable to mix these two worlds and create awesome experiences. I could also, I don't know, let's try orbit controls, place them into the scene, and now I can turn it around, zoom it, pan it. So that's how you can mix. So going back to this one, because it adheres to all the principles I've been talking about, it's mixing and matching DOM content, which is fully responsive, accessible with 3D content, as you can see here in the perspective shift. And this is a very interesting topic to me, to use the DOM for typography, for fonts, for layout, responsiveness, and the GPU for everything else. And this can create some pretty smooth and exciting experiences. If this interests you, I've made a full tutorial about this on CodeJobs called Scroll, Refraction, Shadow Effects in Three.js and React. And it's teaching you the basics, how to bind objects to the scroll bar, how to mix and match DOM content in 3D, how to put some shader effects on it, and in the end it looks like this, pretty far out. I guess it doesn't have to be as drastic as this one, but I just wanted to show that it's possible. I've made another one. This is a side scroller. The harder you yank on it, the more pronounced is the effect. And you can also hover over the minimap and drag it. That's my dad, by the way. He's a hunter. This one I wanted to show you because it's pretty special to me. This is the first game I made. And I thought that games will be completely different because I come from frontend, but it wasn't like this. In the end, everything is a state machine. And you can see here how clean and tidy it is because it's React. Everything is packed away and encapsulated. And now we can also hot reload stuff. Let's take out the stars, the track, planets and rocks. And you see, notice how everything keeps going because the state hasn't been affected. Let's mount them back in and maybe remove effects because makes the most difference. This is how games look without effects. Put them back in. So I'm basically through. The only thing that's left is I'm going to show you a couple of libraries because there's been the ecosystem around React Free Fiber has been pretty active, and these are the first libraries that sprang up. This one is called useCanon. It's for physics using the famous lib, what's it called? Canon.js. And it allows you to put physics into your own applications. Very easy to use. It's hooks based and it's not as complex as you would think. It's pretty cool. And this is React Spring, a React animation library. And it's also completely compatible to React Free Fiber. For instance, in this example, in the background, the 8 that you see there in green, this is HTML, and this ping pong ball and this trap, this is React Free Fiber or Three.js. And React Spring is animating both. So this is made possible by Alec. In version 9, you can share springs and animate everything. And last but not least, there are a couple of others. React post-processing. This is for the post-processing library on NPM, which is for effects. We'll make it very easy to use effects in a declarative way. Then there's dry, I showed you earlier. This one could be exciting, React XR. It's for virtual reality. It will basically deliver utilities for this to make it easier. Use gesture, like the name implies, is for gestures, moving things around and so on. So I am pretty much through. Sorry for sticking with me and my coarse voice. I'm completely messed up by now. So I hope you enjoyed this talk. I hope it interests you. If you want, check out these libraries and let me hear on Twitter or on GitHub if you have problems, if you like it, if you have suggestions. We are always open and these things are welcome. So thanks a lot. And again, thanks for having me and have a good one. Bye.
So it seems like it's pretty easy to get started with this rather than Three.js. And I noticed it seems that you can go to the Three.js documentation and still be able to use that along with your library pretty easily. Is that correct?
Yeah, that's totally correct. There's no real split. Some people, they immediately assume that React Free Fiber introduces new rules or something like that. It doesn't. You need to know what Three.js is. You need to know the basics to even be able to use it. And you can basically also use it in the same way. You don't have to make it declarative. But in the end, you will figure out that you should, because it makes many things easier as you have seen.
Yeah, and if anyone's looking to get started with this library very easily, there is a talk that he does with Jason Langsdorff on YouTube, which is like an hour or more long, which I thought was really great to kind of get you introduced. And we had a question, actually one from the chats, which was, are you going to be sharing any of those code sandboxes? And is that something maybe you could make available on Twitter with some, I don't know, maybe you could tweet some of those code sandboxes out?
Yeah, sure. That's basically my whole game on Twitter. I do nothing else. I don't put personal stuff on it. It's just the libraries I'm working on. I'm sharing Code Sandboxes. Code Sandbox liked it so much that they gave me free pro access, because I'm sharing. I'm like spreading the word.
Yes.
But the problem is there's no. I don't know if it exists. Something like a gallery where I can collect all the stuff that I have done. There's like hundreds that I've made, and they're all floating around on Twitter, on GitHub. It's kind of a problem. I would like to collect them all at some point.
Great. And I noticed integration with things like 3D modeling programs like Blender.
Yeah, it's not that you integrate it with Blender. It's the stuff that we are doing at work is almost like a Blender for the web. We will publish this very soon. Then people can try it out. If you have seen Blender, then you open it up as a software, and then you start to construct your models, and you will basically be able to do this in JavaScript. This is the work. This is where React Fiber actually comes from.
How about you, Sean? You got any questions?
Well, one thing I think that people would be interested in is using this together with React Native or Expo, the Expo version of React Native. I don't think I've seen ports. It probably is possible, but I just figured I'd ask you.
Yeah, it's totally possible, and with Expo, it actually runs native. So it's not in a web view. It runs in OpenGL ES. This was done by a company called Ueno, and the guy that made it was called Birkir, but his last name I wouldn't be able to pronounce it. But it works. I'm not so familiar with React Native, but I've seen other people do it. Yeah.
Because I think it's very because on a React Native app, it doesn't really matter if you're choosing DOM or Canvas, and if you can do all these slick animations, and it's so smooth, you might as well just do it all on Canvas.
Yeah, I mean, maybe even for the web. I think Ken Wheeler, he tried for a long time to find some like connecting ground. It's an interesting topic for sure.
Yes. So cool. I noticed that obviously it's going to work great with React Spring. You're also contributor author of that library. We had a question from Discord. What resources would you recommend to someone wanting to learn React Spring, animations, and 3D modeling? I think it fits in here.
I think the best advice that I can give is start simple. Go to the repositories, check out what's written on them. React Fiber gives you some starting points, like a couple of tutorials that you can check out. Really easy stuff. I myself, I'm not even too familiar with Three.js. I couldn't make some, I don't know. I'm self-taught. I know very little, and I have no math background whatsoever. I know this scares people. So it's not so hard as it seems. And the same goes for React Spring. If you have a problem, like animation-wise, I would start there. I would start to solve this, and then maybe go venture further. All the informations are on the GitHub repos, and I think the philosophy of the React Spring organization is that most of these libraries, they should be simple as possible, but still explicit, like no magic. And I wanted at some point to make it possible that each repository lists the full API on the front end, on the GitHub front end. For React Spring, we haven't made it. The API still got a little too big because it can do lots, but start simple. Don't go overboard. That's the advice I can give.
And I think that that's good to hear, and it makes it more approachable by all of us. I also just wanted to thank you for the talk, because we have a lot of people in the chats just saying, you know, jaws dropped, a very great talk. So again, thank you for that. And
before working on this, you were the creator of Paranoid Android, and you talk about this, but what happened to? I think this was bought by OnePlus or something.
Yeah, Paranoid Android was a really popular Android firmware or ROM. I started this. I made most of these features for this. Really crazy stuff. If you've never seen it, go check it out. It was an awesome time, but I got bored because I hate Java. And my computer was slow. I burned through several laptops of mine because it takes a long time to compile the firmware. It takes a whole night, and a couple of them burned through. So I got bored and didn't want to waste my time. But it was a good time. It was my first open source experience.
Nice. Okay, well, thanks so much, Paul, and we're going to get started with the next talk.
Sorry for the accent.
Welcome.
And thank you.
Welcome. Thanks.
It sounded great. Thank you.
Great.
Great
yeah, sure.
Thanks for joining us, Paul.
Bye.
Bye.